Bismillahirrahmanirrahim. This is a June 2021 and the one variant question number we have given here. This is a two functions called a parametric equations given and we have to differentiate. First of all, students, whenever logarithm given, what is way of doing? Dx over dt, x comes up and this t from variables goes down. And what is method? After logarithm, whatever in the bracket will go directly without any change. In the numerator, this bracket value differentiation will come. Like 2 has a 0 and 3x become 3. That's it. You write only 3 or display, no problem at all. So finally, I get this answer. And what about this? But here two functions are dividing. So I will apply quotient rule, dy over dt. And according to criteria, what is the basic right rule? Whenever two functions dividing and you want to differentiate, so basic criteria, whatever in denominator, take square of it. Which function is squared, leave as it is into differentiation of the upper part. And minus now opposite. Opposite means now you copy v dash. So let's apply same thing. So this square, I'm writing 2 plus 3 to the whole square, which you squared, I will copy as it is into differentiation of upper function 1 and minus now opposite, now t copy into this function derivative 2 has 0, 3t becomes 3. And I believe this is nothing hard. Simplify. So 2 plus 3t, 3 into t, I got negative 3t. And negative 3t and positive 3t will cancel out. So Alhamdulillah Rabbil Alameen, this is very clear, this cancel out. And I get dy over dt. And finally, I get 2 over 2 plus 3t whole square. Now I'm writing here by chain rule. Why reason? Whenever more than two variables involved in the question, we use chain rule. And how many variables involved? X, y, and t. What is my target gradient? Y with x. Okay, so I mean dy over dx is my target. I will write two fractions. This will come in first numerator. This will go second denominator. So dy I'm writing here. Dx is coming here. What is the third variable? Is t. So dt I'm writing here and dt I'm writing here. Now this value is this matching? No. This x down t up here, x up t down, reciprocal. So I will flip it. So 2 plus 3t up and this 3 will come down and this is fully matching, so copy paste. So this is, I think up till here, no confusion at all. Because this base are matching, this fully cancel, the power gone. And ultimately I get what? 2 up, 3 times 2, 2 plus 3t. So this is my answer. So first part is done completely. He was asking for show that gradient of the curve is, he said gradient of curve is a positive. And now I have to prove it is gradient of curve is positive or not, okay? What is the method? Show the gradient of curve is always positive. This is our target. Hold on. Basic criteria is what? You can see this value is this matching, okay? And this value look at here, it cannot be negative. Why, sir? Because in the logarithm part, whenever we have value, if you get a negative answer, it give you undefined math error, not possible, no solution. To avoid this, so the value in the bracket must be positive. Okay, then it give you some value it will give you confirm. Okay, and this value in the bracket is matching with that. I mean, look at here, 2 plus 3t, 2 plus 3t, and this is a 2 plus 3t. And as you know that, but what a question he was asking, show that gradient of the curve is always positive. And you know it very well because as this function is defined, there is only possibility we can say that as x is equal to logarithm of 2 plus 3t. Okay, this and now as we have x value 100%, this value is positive, right? So x exists only if 2 plus 3t is bigger than 0, or you can say positive answer. So if this is a positive, so this is a positive. If this is a positive, so we can say that hence dy over dx will be, because if this is a positive value, 2 is already positive, 3 already, so I got a positive. So what a question he was asking, show the gradient is always positive. So alhamdulillah rabbil alamin. So gradient will be positive always. And I believe you got a point very clear. And this first part is over. And let's go for part number 2. So next part, students, we have find equation of tangent to curve at the point where the curve intersect y-axis. And all of you know when curve intersect the y-axis, we put always x0. Okay, students? So we will put x0 always because intersect the y-axis. So where to put x0, students? Naturally, we have these equations. Okay, so I'm using this equation. X is equals to logarithm 2 plus 3t, and this equation, and then I'm writing second equation also. Y is equal to t over 2 plus 3t. These two equations I need. Okay, so and I paste here. All right, so I need this both values here. All right, so you will see now this value, get it here. Common sense, what is the way? Whenever we're looking for equation of tangent, we need two things. Look the formula I'm writing. Y minus y1 equal to mt, I'm a grade of tangent, time to x minus x1. So we need three things, m1, x1, x1, y1, and gradient. Okay, x1, we know it, x is equals to 0. But how to find y value? Can I plug in this value directly here to get y value? Impossible. I have to plug in this 0 here. I will get t from here, and that t plug in here to get y. So some extra process. So let's first of all, I plug in 0 here. So when I plug in 0 here, some student getting issues how to get t. So whenever 0 here, I can remove by ln1 because all of you know ln1 is also 0. And why I wrote ln1, you will come to know after a short interval. Look, they cancel out. This is the main reason. So 1 equal to 2 plus 3t, and this 1, 2 goes there, negative 1 equal to 3t, and t becomes a negative 1 over 3. This value of t, I will plug in it there to get a y value. So have a look now, students. So y is equals to negative 1 over 3, 2 plus 3 times to t value, which is this here, negative 1 over 3, 3 cancel. I got negative 1, 3, and here I got a 1. Ultimately, because this 1. And ultimately, I got a y value minus 1 over 3. Now, student, this value will come here. So minus 1 over 3, I'm writing it here. And x1 is coming 0 from there. So no issue at all. But only thing is left, gradient. What is a gradient? And we have the derivative already. I will use this equation and find out a gradient. And say, see now, copy, and I'm going to paste here. I'm going to paste here. So this value, I have it. Okay, students. And wait a minute before I use it. Wait a minute. Okay, I bring this equation here. Okay, and I'm looking for, I will plug in this t value here so I can find the gradient. So what is gradient of tangent by default? 2 over 3 times 2, 2 plus 3 times 2, negative 1 over 3. Negative 1 over 3, hold on. Yeah, here. So I'm writing here negative 1 over 3. 3 cancel. I got 1. I got ultimately gradient is coming 2 by 3. So gradient is coming 2 by 3. This value I'm going to plug in here. Now, student, 3 will multiply left hand side. When 3 multiply with y, I get 3y. 3 multiply with this, I get a plus 1. 2 multiply inside, I get this. And ultimately, 3y equal to 2x and minus 1 is my final answer, which he was asking us. So I hope so you got a point.